Hello, welcome to this video. We are going to talk about logarithms, a new type of function that is the inverse of exponential functions. And in this video, we're going to go ahead and introduce logarithms and then also kind of show you how they are derived from their inverse exponential functions. All right, so let's go ahead and start off with an exponential function. So a function such as 2 to the power of x accepts values of the exponent as inputs, and then it delivers corresponding values of the power as outputs. Well, the inverse of an exponential function, as I said, is a logarithmic function. Can you say that? Logarithmic function. The inputs of a logarithmic function represent the value of a power, right? So inputs and outputs switch with an inverse function. Okay, the corresponding outputs represent the value of the exponent. Okay, and this makes sense, and I'll show you a diagram. There's also one right behind me here on the board that again kind of shows this relationship. Okay. Now, an important thing to remember about logarithms is that logarithms have bases, and just as exponential functions have bases, okay, and again, we'll dive into that in a second, but for a function 2 to the power of x, the inverse, which is a logarithm, is going to be read as log base 2 of x, and there's a couple of ways you can read this. Again, like I just said, the common way is this: log base 2 of x, or you could say the logarithm with base 2 of x. But again, the most common one is the latter. Okay, and again, a key concept to remember here that a logarithm is equal to the exponent value. Okay, so let's go ahead and kind of introduce a logarithm and what it is. So here is a graph of 2 to the power of x, and we are asked to graph its inverse on the table. Maybe you're asking yourself, hey, how the heck do I do that? Well, remember, an inverse, inputs and outputs switch. So here, if I have this value here, this is -2, 0.25, and then I have this ordered pair here. This is -1, 0.5, 0, 1. We have 1, 2, 1, 2, and we have 2, 4. Well, if I want to go ahead and graph its inverse, all I'm going to do is I'm going to switch these inputs and outputs. Okay, so I'll go ahead and do this here on the table. So 0.25 is paired with -2. 0.5 is paired with -1. 1, 0, 2, 1, and 4, 2. Oh, I guess I'm missing this one. This is 3, 8 up there, but well, I can add it to the table. Doesn't hurt. Okay, so here is a logarithmic function, and what I'm going to do now is I'm going to go ahead and plot these values. So 0.25 -2 is roughly here. 0.5 -1, 1, 0, 2, 1, 4, 2, and 8, 3. So here is a logarithmic function. Okay, and something that you'll notice about a logarithmic function is that it has a vertical asymptote at x equals 0, so it will never ever touch this this axis. It will never move, right, unless we have translations. Okay, but yeah, so that's what a logarithmic function looks like. Okay. So how do we go ahead and define a logarithm? Well, in general, the exponential function f of x equals b to the x, where b must be a positive value, okay, that's not 1, has the logarithmic function f inverse of x equals log base b of x as its inverse, okay? And again, the diagram is down here. This will make it very clear, but if f of x equals 3 to the power of x, then f inverse is going to be log base 3 of x. Another example, f of x equals 1/4 to the power of x, then f inverse is log base 1/4 of x. And the key idea here is that the bases are exactly the same. Okay, so b to the power of x, it's log base b. And then inputs and outputs switch. Inputs and outputs. Okay, so if I have b to the power of x is equal to a, then my logarithm is going to be log base b of a is equal to x. Okay, inputs, outputs, switch. I can't say it enough. So let's go ahead and look at some examples. So here we're asked to complete the table by writing each of the given equations and its alternate form. So here I have 4 to the power of 3, 4 to the power of 3, 4 to the pour of 3rd is equal to 64. So this is going to be log, okay, base is the same, 4, okay, and then the input, sometimes you'll see parentheses, sometimes not. I'm going to use parentheses here, of 64 is equal to 3. Inputs, outputs, switch. I would write that down. Okay, now if I have a logarithm base 81 of 3 is equal to 1/4, how can I write that as an exponential form? Well, again, base is the same. 81 to the power of, okay, well, inputs and outputs switch. So it's 81 to the power of 1/4 is equal to 3. Pretty easy, right? 2/3 to the power of p is equal to q. Well, as a logarithm, that's going to be log base 2/3 of q is equal to p. And an important thing to remember, make sure that these logarithm values here, these are subscripts. So they're kind of like smaller than the rest of your writing, okay? So make sure you don't write it like super big. Okay, here I have log of 10,000 is equal to 4. And then here I want to let you know that this is what we call a common log. Common log. And with a common log, this is log base 10. Log base 10. So really there's an invisible 10 down here, okay? So we have base 10 to the power of 4 is equal to 10,000. All right. Okay, next, 5 to the power of -2 is equal to 1/25. Well, again, as a logarithm, this is log base 5 of inputs and outputs switch. 1/25 is equal to -2. Okay, and then I'm going to go ahead and introduce another logarithm. So I would highlight these. These are very, very important. The common log, and then we have here the natural log. Okay, and the natural log is log base e, which log base e we write as ln. Why is it ln if it's the natural log? Well, it's Latin for logarithmus naturale. Don't shoot me if I said that wrong. I don't speak Latin, but that's what it is. You can Google it. It's there, I promise. So this is log. Okay, base stays the same. E, inputs and outputs switch. So of 7.389 is equal to 2. Now I'm going to go ahead and I'm going to rewrite this. So we don't write log base e. I don't even want to say you can. What we write is we write ln. So ln of 7.389 is equal to 2. Well, not equal. I want to say approximately. Okay. So these are the two common logs, or the common log and the natural log. You'll commonly and naturally see them in mathematics. They're the most frequent ones that you'll see. All right, so I have some practice problems here. I would like you to go ahead and please try these on your own. Pause the video now, and I'll show you the solutions. Okay, so I'll assume that you have tried these. Here is the solutions. See if you got them right. All right, so that's it for this video. I have introduced logarithms, and we've talked about how to switch from exponential form to logarithmic form. That's an important kind of skill that you'll need going forward for the rest of Accelerated Math 3 as well as Calculus. And in the next videos, we're going to go ahead and talk about how we actually evaluate logarithms or solve kind of equations. All right, catch you next time. Peace.